Hey guys, Andrew here again. In the last video we took a look at subnetting down using VLSM, a Class C address with a .128 here, so I believe a 192.168.10.128/25. Gave you an example of that, and we also, a video and two videos back, we looked at standard Class C networks using magic number. Right, and we could see with magic number that we could turn around and we could say, can we find the magic number for a network with X amount of hosts, right? I had maybe I had 100 hosts, and I would look at this guy and I'd say, all right, I'd look at this, this table here, and I would borrow bits until I had the exact magic number. Well, in B-class addresses, doesn't really work that well, right? At first glance, magic number seems broken, all right? But it isn't, all right? What we do know is that in a Class C network, right, this guy right here, each octet can only hold a maximum of 255 total values. So I can only go from 0 to 255 in this one octet. And this octet can only go 0 to 255, and this one can only 0 to 255 and 0 to 255. That's the maximum range, because these are 8 bits apiece, and again, in an 8-bit value, if I put all ones here, right, just like I have in my subnet masks, if I have all ones in this entire thing and I add up all these values from my ones in binary, I get 255. All zeros gives me 0, so my max range is that 0 to 255. Or 256 total, right? Including 0. So 0, 1, 2, 3, all the way up to 255. All right, so with that being said, if we go into a Class B network, we kind of saw this a few videos back. I gave you a /23, and I said, hey, looking at this /23 network, we can, we can find the network first last broadcast, and we found that the network address was .0.0. I think I did a 172.20, something along those lines. 172.20, or in this case, .16, 0.0. And then the next network in that /23 was, or the broadcast was 1.255. Because again, this range here goes from 0 to 255. If I want to go up more, if I want more addresses beyond the 256, I gotta start incrementing this third octet here. Okay, so in this /16, it's going to be, it's going to start to look like how many /24 or Class C addresses can I fit inside of here to, create different size Class B networks. Okay, so let's say I've got a network and I need to know, I got to come up with a network. I've been given 172.16.0.0/16, right? This is my network that I'm given. Here's the subnet mask written out in decimal for this /16, all right? And I've got this, this 15,000 hosts, all right? So I know I need 15,000 hosts, okay? What I can do is I know that I have 15,000 hosts, right? And let's divide that 15,000 by my 256 for each of my Class C networks. And we're going to see how many Class C networks, /24 networks, we can fit inside of this 15,000, all right? And if we do that, 15,000 divided by my 256, I get a value of something crazy here, right? I can fit 58.59375, right? Well, that's kind of a ridiculous number, but it does tell us something. It's more like 58 dot something, okay? What we can do is we can take this 58, we could even, 58 here, and we're going to see if we can't take this 58 and stick this 58 into our binary chart here. Now, keep in mind that our network, this is the network and these are the hosts over here. So this block here is actually going to represent this guy right here. Okay, 0, 0, 0, 0, 0, 0, 0, 0. Okay. So, can I put 58 inside of 128 networks, or 128, right? Yes, I can, so I could borrow this guy. All right. Boop. What about this one? Can I put 58 inside of 64? Yep, I can do that. Could I put 58 inside of 32? No, I cannot do that, right? So I can actually fit this in. I can put my 58, this 58 value here, inside. I can borrow 2 bits inside of this address here. All right, so in the past, in Class C networks, we looked at this and we said, all right, well, we were always looking at this value and we're trying to stick it in here, and we were doing the, is this, you know, can we fit 65 inside of 128, but it's really 126. We're not working with that, you know, we're still using this, but we're not trying to, we're not doing that, the -2 here when we're dealing with B-class addresses, right? Because we just found out how many networks of 256 would it take to pack into our 15,000, right? And so now looking at this chart here, we can figure out that our magic number in this case is 64, as we can borrow 2 bits, we can fit this 58 inside of this 64. All right. So because of this, we now know that our new subnet mask, right, or our subnet, right, will start at this 172.16.0.0. We borrowed 2 bits here, so this is a /1618. It's going to be 255.255. Well, this is 128 plus 64 is 192.0. All right, and given this information, I can now go through the network first last broadcast to determine what my network first last and broadcast addresses are in this given network. Okay, I can also see that my networks are going to go up in increments of 64. Okay, so I can now tell that my next network here would be 172.16.64.0 slash whatever. All right, so my broadcast range would be, my range here would be 172.16.0.0/18 to 172.16.63.255 for my last address, which would be my broadcast address in this case. Okay, so a little bit of a roundabout way. We can still use magic number. Some of the things change here. Again, we're dealing with a much larger range. You have to remember that each of these octets can only handle 255. So really, this is like looking at how many Class C networks, how many /24s can we put inside of this 15,000. You know, how many of them can we pack in there to get to our 15,000 addresses, all right, in this network? And we found out we can do roughly about 58.5. Really, we're really looking at this value right here, this whole number. This does play a part in it, but really that whole number. And we're saying, can we stick that whole number, what's the smallest value we can stick that whole number in? So can we stick the number in 128? Yes, we can, so we borrow a bit. Can we stick that number in a 64? Yes, we can, so we borrow a bit. Can we stick 58 inside of 32? No, we can't. So 64 becomes our magic number. Once it becomes our magic number, we now know where our networks will, it starts at 00 and it's going to go up to 64, right? And then finally, how many sub-networks does this create, right? Well, in the past, we saw that 64 would create in a Class C network, right? 64, 64, 64. That would create 4 of them. In our case, we got our 256 here, right, for each of our networks. And we're going to have 64 of them will actually give us our total value here, all right? And we will get a value of 16,384, right? So we're actually putting that 15 inside of here. But if we take that 1684 and we divide, let's grab it right here, a /16 network gives me 65,536 total hosts, and I take my 16,384, I can find out that I have 4 networks of that. So I'll now have 4 networks of 16,384, and each of those rotates on this 64 block based on my magic number. So a little far-fetched, a little roundabout way of going about this. In the next video, I'm going to take a look at an example here. I'm going to be giving you a Class B range. Might not be a /16, might be something a little bit different. But we're going to break down, given that Class B range, we're going to take it down, and we're going to have 3 different networks here. We're going to use VLSM and the magic number rule, and again, this value here, taking the total number here and dividing by how many Class Cs can I pack into that network, all right? And then we're going to go from there. So I'll see you guys in the next one for an example with VLSM and Class B.